Here we're going to talk about what are called the double angle formulas. So we're going to start by recalling. So recall the sum formula for cosine. Recall that cosine of a plus b, that's equal to cosine of a times cosine of b minus sine a times sine b. Now if you use this formula except for when the angles a and b are both the same angle theta, then what happens is if you have this cosine of theta plus theta, right? A and b are both equal to the same angle. Now on the one hand, that's simply equal to cosine of 2 theta, right? Because theta plus theta is simply 2 theta. But if you also expand it using the sum formula, you get cosine theta minus sine theta, sine theta. Now this is simply cosine theta times cosine theta, and so that's just cosine squared theta. And likewise over here, that's just sine squared theta. So we have the first form of the double angle formula for cosine of 2 theta. That is cosine of 2 theta is equal to cosine squared theta minus sine squared theta. This is the first form of the double angle formula for cosine. Now it turns out that there are 2 other forms, and the reason is because recall that we have an identity sine squared theta plus cosine squared theta. We know that's always equal to 1. So if you use this to isolate sine squared, you get sine squared theta is equal to 1 minus cosine squared. And then what you can do is you can replace the sine squared with this, right? 1 minus cosine squared theta. So this can be rewritten in the following way. It's going to be cosine squared theta minus, okay, sine squared theta is 1 minus cosine squared theta using this, right? Now you can take that negative and distribute it, and that's going to make this positive. So it's going to become cosine of 2 theta is equal to, you're going to have a positive cosine squared theta, and you're going to add that to the cosine squared theta you already have to give 2 cosine squared theta. And then don't forget minus 1. Now this is an alternative form of cosine of 2 theta. Now which one do you want to use? Well, whichever one's convenient in the problem you're working on. Now it turns out there's yet a third expression for cosine of 2 theta, and you can see why. Instead of replacing sine squared theta, you could of course replace cosine squared theta. So let's do that now. So cosine of 2 theta can also be written as, well, replacing cosine squared theta, you're going to replace that, of course. If you isolate cosine squared theta, that's going to be 1 minus sine squared theta. So you can replace that with 1 minus sine squared theta. And then don't forget, still minus sine squared theta. And then when you combine like terms, you get cosine of 2 theta is 1 minus 2 sine squared theta. And this is the third form for the double angle formula for cosine. Now, it turns out that there's also an expression for, or there's also a double angle formula for sine. So let's play the same game. Let's recall, let's do that over here. Let's recall that sine of a plus b, that's equal to, well, it's equal to sine of a cosine b plus sine b cosine a. So if you then over here, if you do the same thing and you write sine of theta plus theta, right? And on the one hand, the obvious is that this is equal to sine of 2 theta, because theta plus theta is 2 theta. Okay, now, but if you expand it out using the sum formula where a and b are theta and theta respectively, you get sine theta cosine theta plus sine theta cosine theta. So let's write that down. Sine theta cosine theta plus sine theta cosine theta. And now you can combine like terms because these are the same. So you get 2 sine theta cosine theta. And that, of course, is equal to sine of 2 theta. Okay, so this is, now there's only this form for the double angle formula for sine. So you have 3 forms for the double angle formula for cosine. and just 1 for the double angle formula for sine. Now the question is, when can we use these? Let's go ahead and see that, some applications now. So let's solve this equation. We're looking to find solutions in the interval from 0 to 2 pi. And here's our equation. It's cosine of 2x plus cosine x equals 0. And the difficulty lies in the fact that it's not, the arguments are different. This is 2x and this is x. So what we're going to do is we're going to replace that cosine of 2x, making use of a double angle formula. Let's go back to the double angle formulas and decide which one we want. Now keep in mind that there's a cosine x here, right? So we're going to replace the cosine of 2x. Let's go ahead and look back at our options. Okay, here are our options, right? So option 1, 2, or 3. Now, if you use option 1, you're going to have a cosine squared and a sine squared. And then you're going to have to also deal with the cosine that's in your original problem. So let's not use this one. Option 2 is actually the one we're going to use. And the reason is because you see how it just has cosine squared? When we have a cosine squared and the cosine that's an original problem, we'll have an equation that's what we say quadratic in form involving cosine. And we don't want sine squared because that's just going to make things hard between having a sine squared and a cosine. So we're going to replace cosine 2 theta with 2 cosine squared theta minus 1. Let's go back to our problem now. So we said we're going to replace this with 2 cosine squared x, not theta, but x in this case, minus 1. And then we still have plus cosine x is equal to 0. So the reason we did that now, of course, is because this can be written with the factors of cosine in the terms involving cosine in descending order. So let's write that as 2 cosine squared x, right, the square of cosine, plus cosine x, and then let's write minus 1 finally is equal to 0. Now the reason I wrote it like that was so that we could see that it's actually quadratic in form. Let's write that down. And when we have equations that are quadratic in form, what we do is we imagine replacing, in this case, the cosine with a u, so that we could identify something and then something squared. So if you replaced, everywhere you see a cosine, if you replace it with a u, this would be 2u squared plus u, and then minus 1 is equal to 0, right? Imagining replacing the cosine x with a u. Now this can be solved because it's quadratic, right? You can use the quadratic formula, or it's easier to solve by factoring. So we can factor that left-hand side. So it's going to be, let's see, well, 2u and then a u, and it's going to be plus 1 and minus 1 will do the trick. Now, the benefit of doing it this is that now you go back and say, oh, wait a minute, we don't have u, we have cosine x. So you basically have these factors, but instead of u, you have cosine x. So it's 2 cosine x minus 1, that's this one, right? 2 cosine x minus 1 times cosine x plus 1. And that's equal to 0. Okay, so the important thing now is that we have the left-hand side factored and the right-hand side is 0. So we're going to set those factors individually to 0. 2 cosine x minus 1 is 0. That's one option. The other one is cosine x plus 1 is equal to 0. Now isolating the cosines, we get 2 cosine x is equal to 1. So cosine x is equal to a half. And then over here we get, well, simply cosine x is equal to negative 1. So solving these trigonometric equations, well, we have to think of angles now between 0 and 2 pi, such that cosine of the angle is 1/2. Well, let's see, that's going to occur when x is pi over 3, right? That's one option, 60 degrees, and the other option is going to be 5 pi over 3. So these are solutions of this equation. Now for this equation, cosine x is negative 1, that's going to be pi. So I have a total of 3 solutions. There they are. Now, these are solutions simply because we had to restrict our angles to be between 0 and 2 pi, and then also to satisfy these equations. Okay, let's see some other applications. So the first one, rewrite using a double angle formula. and we have sine multiplied by cosine. Now this occurs fairly frequently. In a lot of the applications you're going to do, like in physics or engineering or in future math classes, you're going to see sine and cosine multiplied together. And sometimes you want to rewrite those using a double angle formula. Now recall that sine of 2x, recall that's equal to 2 sine x times cosine x. Do you see the product, sine x times cosine x, that we're dealing with? So what you can do to isolate 2 sine x cosine x is divide both sides by 2. And then these will cancel, and it tells you the product, sine x cosine x, is equal to sine of 2x divided by 2. So this is sine of 2x divided by 2, which is the same thing as 1/2 multiplied by sine of 2x. I simply took the factor of 2 in the denominator, or the 1/2 if you will, and I factored it out. So this would be my answer. This is what's meant by rewriting using a double angle formula, right? Because we made use of the formula and we ended up with a double angle in there. Okay, how about this one? Finding the exact value of sine of 2u, given that cosine of u is -3/5 and u lies between pi over 2 and pi. So first of all, we're looking for sine of 2u, right? But we know that's equal to 2 sine u cosine u. Now, we need to find sine u, but we already have cosine u, right? Cosine of u is -3/5. The question is, can you find sine u knowing cosine u? And the answer is absolutely. We can make use of an identity, right? That the identity that's always true is sine squared u plus cosine squared u is equal to 1. So that means you can get sine of u if you know cosine of u. So sine squared u is 1 minus cosine squared u. So now we're going to make use of the square root property, and that's going to generate a plus or a minus. So sine of u is plus or minus the square root of 1 minus cosine squared u. Now the question is, which of these do we want, positive or negative? Well, sine of u is equal to this, right? But u lies between pi over 2 and pi. Now that would be in quadrant 2, right? If the angle's between those two if u is between those two angles. Now sine of an angle that's in quadrant 2 is positive, and that's why we want the positive, not the negative. So let's go ahead and write that. Sine of u is just the positive square root of 1 minus, right? I disregarded the negative, just the positive. 1 minus, okay, let's replace cosine of u squared, right? Cosine of u is -3/5, so we're going to take the -3/5 and we're going to square it, because it's cosine of u squared. And that's equal to, let's see, square root of 1 minus 9/25, and that's equal to the square root of, well, let's see, this is 25 over 25, take away 9 over 25, which is 16 over 25. And the square root of that is 4/5. So that is our sine of u, it's 4/5. So coming back over here, it's 2 times 4/5, that's what we just found, right? Sine of u. And cosine of u is given to be -3/5. Now if we multiply all these together, we're going to get a negative 24 over 25. And that would be sine of 2u. And this would be our answer. Now that being said, there is another way to do this problem. And what you could do is, instead of using this identity, you could make use of, or find x, y, and r. That is, what you could do is say that cosine of any angle is x over r. So x would be -3 and r would be 5. And then y, of course, you'd find to be 4. So you'd find, again, that sine of u is 4/5. So you can use either way. I wanted to use this way just to change things up a little bit. But using x, y, and r is fine as well. Okay, what else can we do with double angle formulas? We are going to verify this identity. Now, an identity is something that is always true no matter what the angle. And the way you verify identities is you start with one side and you show it's equal to the other side. So imagine there's a great wall right here, and you have to pick one of the sides. Do you want to work with this side and then simplify that, or do you want to work with this side? Now we usually start with the more complicated of the two sides because that just sort of gives us more options. So let's start with this whole left-hand side, and we're going to simplify it and show that it's equal to this. So here we go. We're going to start with 4 sine u cosine u multiplied by 1 minus 2 sine squared u. Okay, now let's see. Sine u cosine u, right away when I see that I say, oh, sine and cosine are being multiplied together. That reminds me of the fact that we know that sine of 2u, right, that's equal to 2 sine u cosine u. We've seen that before. So what I can do is I can break off a factor of 2 there. I can write this as 2 multiplied by 2 sine u cosine u. And then I still have 1 minus 2 sine squared u. So what I did is I said, hey, look, I can write 4 as 2 times 2, and I put one of the 2's with this, with sine u cosine u, so that I could now write that 2 sine u cosine u, which I've got, is sine of 2u. So this is going to become, right, that 2 is still there, but this whole quantity in parentheses, that becomes, or that is, sine of 2u. So sine of 2u. Okay, and then multiplied by, now this 1 minus 2 sine squared u, you may recall from the very beginning, right, we've seen that before. That happens to be, well, something involving a double angle formula for cosine. Let's go back to that original page now. So you're looking for 1 minus 2 sine squared u. So it's a flashback. Okay, do you see it? 1 minus 2 sine squared u. That's equal to cosine of 2u. Going back to our problem now, cosine of 2u. This whole thing is cosine of 2u. Okay, now if I remove the brackets, what I'm looking at is this. 2 sine of 2u times cosine of 2u. Now, this formula right here, yeah, it involves, I wrote it with u, but it holds for any angle, right? So it's true in general that sine of 2 theta is 2 sine theta cosine theta. Now imagine here that you had some, whatever the theta is here, when you double it, you get this right here, right? So on the right-hand side, it's simply theta, but on the left-hand side, it's double theta. Now I want you to look at this problem. Imagine this is our theta, right? 2u and 2u. Well, look, it's like a 2u and a 2u. But this is double 2u, and that would be sine of 4u, right? So what you need is this on the right-hand side. You need a 2, you need a theta, and a theta. And I've got that. I've got a 2, and a theta, and a theta. So according to my problem, it says, oh, what does that turn into? Sine of double your theta, right? Sine of double whatever theta is. And theta is 2u. So it turns into sine of double the theta. And that's sine of, let me write it like this so you can see it, double whatever you had. The theta in this case is 2u, right there. So I'm doubling that, and that's why I get sine of 4u, right? And that, of course, is what I wanted to show. Okay, so that's how you make use of double angle formulas. And we're going to see that we have other formulas called half angle formulas that are closely related to double angle formulas. Until next time.